Good morning, everyone. Today, I am excited to share with you a comprehensive exploration of strategies for implementing artificial intelligence models in governance. As emerging leaders in public policy, you will find that the integration of AI-driven insights into policymaking can fundamentally transform how governments operate and deliver services. Our discussion will cover several key areas. First, we will delve into the best practices for integrating AI-driven insights into policy decisions. Next, we will examine the infrastructure and technological requirements that underpin successful AI deployments. And finally, we will review a series of case studies that illustrate how AI is being applied in various sectors such as healthcare, transportation, and urban planning. Let us begin by discussing best practices for integrating AI-driven insights into policy decisions. One of the most crucial aspects of modern governance is the move toward evidence-based policymaking. This approach relies on data and rigorous analysis rather than intuition or untested assumptions. With AI, governments can harness vast amounts of data to identify patterns, predict outcomes, and support decisions that are more objective and scientifically grounded. When you incorporate AI into your policymaking process, you are essentially adding a layer of analytical rigor that can help ensure decisions are backed by empirical evidence. This does not mean that human judgment is removed from the process, but rather that it is augmented by insights generated from sophisticated algorithms. In the context of public governance, starting with pilot programs is a critical step. Rather than deploying an AI system across an entire city or department immediately, it is wise to conduct smaller-scale tests. Pilot programs allow you to observe the performance of the model in a controlled environment. During these tests, you can collect data on how well the model performs, identify any issues that may arise, and determine the adjustments necessary for broader application. For instance, consider a city government that seeks to optimize traffic signal timings. Before implementing the system citywide, officials might begin with a pilot program in one district. This strategy enables policymakers to evaluate the system's effectiveness, understand its impact on congestion, and make data-driven refinements that could lead to a successful larger-scale rollout. Another vital consideration in this process is the concept of interpretability. AI models, particularly those that are complex, can sometimes operate as a black box where it is not clear how inputs are being translated into outputs. This opacity can be problematic when decisions directly affect the public, as transparency is paramount in maintaining trust. Therefore, it is essential to ensure that the AI systems used are interpretable, meaning that the reasoning behind their outputs can be explained in understandable terms. When models are transparent, policymakers can explain to citizens how and why certain decisions were made, thereby fostering a sense of accountability and trust. This transparency is not only important for public acceptance but also for facilitating effective oversight and regulatory compliance. In addition to interpretability, establishing continuous feedback loops is fundamental. The integration of AI into governance is not a one-time event, but rather an iterative process. As new data is gathered and as the context in which the AI operates changes, the model must be continuously updated and refined. Feedback loops involve regularly assessing the performance of the AI system and making necessary adjustments to improve its accuracy and effectiveness. By maintaining an adaptive model, governments can ensure that the system remains relevant and continues to meet the evolving needs of society. Now, let us turn our attention to the infrastructure and technological requirements for deploying AI in a governmental context. Before an AI model can be effectively integrated into public policy, it is essential to have a robust and secure data infrastructure in place. AI relies on large volumes of high-quality data that must be stored, processed, and managed securely. In the public sector, where data often includes sensitive information, establishing secure data systems is of utmost importance. These systems must not only facilitate efficient data processing but also ensure that data privacy and security protocols are rigorously maintained. When discussing data infrastructure, one must consider the technological choices available. A key decision in this process is whether to adopt cloud-based solutions or to maintain on-premises data centers. Cloud platforms, offered by major providers such as AWS, Azure, and Google Cloud, offer scalability and flexibility that can be highly beneficial for AI deployments. they enable government agencies to quickly scale up resources as needed and to leverage advanced computing capabilities without significant upfront capital investment. However, cloud-based solutions may also raise concerns related to data sovereignty and control. In some cases, sensitive data stored in the cloud could be subject to regulations or external access requirements that may not align with a government's data governance policies. On the other hand, maintaining on-premises infrastructure provides governments with greater control over their data and can alleviate some of the concerns associated with cloud storage. However, on-premises solutions typically require more substantial initial investments in hardware and ongoing maintenance costs. Furthermore, they might lack the scalability that cloud solutions inherently offer. When evaluating these options, it is crucial to consider the specific needs of the government agency, including the volume and sensitivity of data, budgetary constraints, and long-term strategic goals. Alongside the physical and technological infrastructure, regulatory compliance is another critical factor. AI deployment in the public sector must adhere to various data protection and privacy laws, such as the General Data Protection Regulation (GDPR) in Europe or the Act on the Protection of Personal Information (APPI) in Japan. These regulations are designed to protect citizens' data and ensure that it is used responsibly. Therefore, any AI model deployed by a government entity must be developed and implemented in a way that complies with these legal frameworks. This means conducting thorough data audits, implementing robust security measures, and establishing clear protocols for data access and usage. A practical example of this can be seen in the healthcare sector, where a health ministry deploying an AI system for disease prediction must ensure that the model adheres to stringent data privacy regulations to protect sensitive medical information. Having discussed the foundational elements of best practices and technological requirements, we now move to real-world examples through case studies that highlight how AI is being implemented across different sectors. By examining these case studies, we can gain valuable insights into the practical challenges and opportunities that come with integrating AI into public governance. In the healthcare sector, one of the most transformative applications of AI is in the early detection and prediction of disease outbreaks. The recent global challenges presented by the COVID-19 pandemic have underscored the importance of proactive and data-driven responses in public health. AI models have been developed to analyze data from a variety of sources, including hospital records, social media, and even search engine queries, to predict potential outbreaks before they become unmanageable. These models can provide early warnings to public health officials, allowing them to mobilize resources, implement preventative measures, and ultimately save lives. In addition to outbreak prediction, AI is also being used to develop personalized treatment plans. By analyzing patient data and historical treatment outcomes, AI systems can assist doctors in tailoring therapies to individual patients, thereby improving treatment efficacy and reducing the likelihood of adverse effects. Transportation is another area where AI is making a significant impact. Urban centers around the world are grappling with the challenges of congestion, pollution, and inefficient public transport systems. AI-driven solutions are being deployed to optimize traffic flow and reduce congestion. For example, by analyzing real-time traffic data, an AI model can adjust traffic signal timings dynamically to ensure smoother flow and reduce wait times at intersections. This not only improves the overall efficiency of the transportation network but also contributes to environmental sustainability by lowering emissions. Furthermore, AI is being applied in the realm of predictive maintenance for public transport systems. By monitoring data from sensors installed on trains and buses, AI models can predict when maintenance is required before a breakdown occurs. This proactive approach helps to minimize service disruptions and extend the lifespan of transportation infrastructure. Urban planning is yet another field where AI holds significant promise. As cities continue to grow and evolve, planners face the daunting task of balancing various factors such as energy consumption, pollution levels, and housing demands. AI models can process large datasets to identify trends and provide insights that inform long-term urban development strategies. For instance, smart city initiatives are leveraging AI to monitor and analyze energy usage patterns, assess environmental impacts, and predict future housing needs. These insights enable urban planners to design cities that are not only more efficient but also more sustainable and resilient in the face of future challenges. One notable application of AI in urban planning is in the realm of waste management. Automated waste management systems powered by AI can optimize collection routes, predict waste volumes, and even sort recyclables more efficiently, thereby reducing operational costs and environmental impact. Throughout our exploration today, the recurring theme has been the importance of a methodical and iterative approach to deploying AI models in governance. By starting with pilot programs, ensuring model interpretability, and establishing continuous feedback loops, governments can build AI systems that are both effective and trustworthy. At the same time, investing in robust data infrastructure and carefully evaluating technological options, whether cloud-based or on-premises, are essential steps to ensure that these systems are reliable and compliant with legal standards. The case studies from healthcare, transportation, and urban planning further illustrate how AI can be harnessed to address complex societal challenges and improve public services. As policymakers, your role is to not only understand these technological advancements but also to champion their ethical and responsible implementation. Integrating AI into governance is not without its challenges. There will be technical hurdles, issues related to data privacy, and the ever-present need to balance innovation with accountability. However, with thoughtful planning, a clear understanding of best practices, and a commitment to transparency, AI can become a powerful tool for modern governance. It has the potential to transform decision-making processes, enhance service delivery, and ultimately improve the quality of life for citizens. Before we conclude, I would like to emphasize that the journey toward integrating AI into governance is an ongoing process. It requires a willingness to learn, adapt, and iterate. As you step into roles where you will be making critical policy decisions, consider how the principles we discussed today, evidence-based policymaking, pilot programs, model interpretability, continuous feedback, and robust technological infrastructure, can be applied to the challenges you face. Embrace the opportunities that AI offers, but remain vigilant about the ethical and practical implications of its deployment. In summary, we have examined several strategic components essential for the successful implementation of AI models in governance. We began by discussing the importance of evidence-based policymaking and the role of pilot programs in mitigating risks associated with large-scale deployment. We highlighted the need for AI models to be interpretable so that the decision-making process remains transparent and accountable. We also underscored the significance of establishing continuous feedback loops that allow for ongoing improvement of AI systems. In addressing the technological side of deployment, we looked at the critical role of secure data infrastructure and considered the benefits and drawbacks of both cloud-based and on-premises solutions, with a strong emphasis on regulatory compliance. Finally, our review of case studies in healthcare, transportation, and urban planning showcased real-world applications of AI that are already making a positive impact on public services. As emerging leaders and policymakers, it is imperative that you remain informed about technological innovations and the best practices associated with their implementation. The strategies for integrating AI models into governance that we discussed today are not just theoretical concepts but practical guidelines that can help you navigate the complex landscape of modern public administration. By grounding your decisions in data, starting with controlled pilot projects, ensuring transparency through interpretable models, and continuously refining these systems based on feedback, you will be well positioned to harness the power of AI for the public good. I encourage you to consider how these strategies might be applied in your respective areas of responsibility. Whether you are involved in shaping policies for urban development, healthcare, transportation, or any other sector, the principles we have discussed provide a solid foundation for leveraging AI to drive innovation and improve public services. Thank you for your attention today. I look forward to our continued discussion on how we can collaboratively build a future where technology and governance work hand in hand to create more efficient, responsive, and sustainable communities.